Go. 4.3. We're going to do number 2D, which should have been where we left off on Friday. The directions simply say to factor. So the first step of factoring is, can I take something out of each of these pieces? And I can't. So then I'm going to move on to do A times C, which is negative 60. Factors of negative 60. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Then take a look at the sign of the last number. It's negative. That means that we want one positive, one negative. The sign of the middle number is positive, so our larger factor should be positive. So since we wrote these in order, we can just go down the line and make all the smaller ones negative and all the larger ones positive. Take a look at your pairs and see which one adds to be a positive 7x. That would be negative 5 and 12. Draw your box. Inside your box, your first term goes in the first box. Last term goes in the diagonal box. And your negative 5 and 12 fill up the other two boxes with an X from the middle term. Out of the top row, I can take a 2x out. The bottom row, I can take a negative 5 out. The left side, I can take an x out. The right side, I can take a 6 out. And I'm going to double check that out. My outside multiplies to be my inside. X times 2x gives me 2x squared. 2x times 6 gives me 12x. X times negative 5, negative 5x. Negative 5 times 6, negative 30. So my factored answer is x plus 6, 2x minus 5. If the directions say to factor, there should be parentheses in your answer. Turn it over. We're going to do number 3. Now for number 3, I'm going to show you 3 different paths to the answer. 2 of them will be by factoring, and 1 of them will be just algebraic solving. If the directions said to factor, you would need to know how to factor something that looks like 3a. Okay? The first thing I'd like you to recall about 3a is that there are 2 terms with a minus sign in the middle, and both terms are perfect squares. That's important because that means that they factor with a pattern. That pattern, you may recall from 0.3, is the square root of the first term, the square root of the last term, and one of them will be plus and one of them will be minus. That pattern only works when you have 2 terms that are perfect squares with a minus in the middle. Anything else in the pattern doesn't work. So that skips a whole lot of extra steps. And I know that a lot of times you've practiced the pattern, you've memorized, you've done all the problems you can, and you can repeat it back and teach others, and then you get the quiz and test, and you're like, I can't remember the pattern. So I'm going to show you how to factor it using our box as well. Okay, if we were to factor using the box, we would need 3 terms. We would need a term with something squared, which we already have. We would need a term with just an x, which we're missing. So we're going to put 0 in for that. And then we need a term without any x's. Now we've got the 3 terms, we can do the box method. I can't take something out of all the pieces. So A times C is negative 36. Factors of negative 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The sign of the last number is negative, so I want 1 plus, 1 minus. Sign of the middle number is positive, so I want the larger factor to be positive. Which pair adds to be 0? That would be 6 and negative 6. First term, last term, those should be diagonal from each other. And then negative 6x and positive 6x should be diagonal from each other. Out of the top row, I can take an x. The bottom row, I can take a negative 6. The left column, I can take an x. The right column, I can take a 6. So my factored answer is x minus 6 times x plus 6. Both methods, recognizing the pattern and working through the box method, gave me the same factored answer. If the directions said to solve, like they do on 3, we have one more step to go. We have to take that factored answer, and just like we did on the homework, we would need to set each of them equal to 0. Subtract 6 from both sides. Add 6 to both sides. And my options are x could be 6 or negative 6. The third method is algebraic. Solving this method only works because I have only one term with an x. If I had the 3 terms across with something x squared and then plus something x plus something else, I would not be able to do this method. But because I just have an x squared and it's minus a number, I can use my algebra skills. If I want to get x alone, that means I need to add 36 to both sides. To get rid of a square, I would square root both sides. And there are 2 numbers that I would write here. Positive 6 and negative 6. Because I could take negative 6 and square it, or I could take positive 6 and square it. Both would give me 36. Both of those would work. So that's 3 different ways to get to the same answer. Keep in mind, if the directions said to solve by factoring, you would have to choose from either the green or orange. 3B. First step, can I take something out of all the pieces? I can take a 6 and an x out, and that leaves me with 2x minus 3. Since there are no exponents left inside here, that means that I can't factor it any further. So to solve, we're going to set each piece equal to 0. Divide by 6 on both sides, and x equals 0. Add 3 to both sides. So I have 2x equals 3. Divide by 2 on both sides, and x equals 3 halves. So my solutions are 0 and 3 halves. Let's take a look at 3C. Can I take something out of each piece? I can take a 2. That leaves me with 6x squared minus x minus 1. So once I've taken something out of all the pieces, I'm only going to deal with what's left over. I'm never going to go back to the original problem. So when I do a times c here, I should have negative 6. Then the factors, the signs, the last number is negative, so I can have 1 plus, 1 minus. The middle number is negative, so the larger one should be negative. Find the pair that adds to be a negative 1. First term is 6x squared. Last term, negative 1, they're diagonal. And then 2x and negative 3x. The top row, I can take a 3x out. The bottom row, I can take just a 1. The left side, I can take a 2x out. The right side, I can take negative 1. So if the directions had said to factor, we would have the 2 that we took out from the beginning. Then we would have 2x minus 1 and 3x plus 1. But the directions said to solve, so we have to take it one step further. We're going to set each of those pieces equal to 0. This front piece does not have an x, so we don't need to set it equal to 0. This piece has an x, and so does the next one. So we're going to add 1 to both sides. Divide by 2 on both sides. And we get a possible solution was 1/2. The other solution, subtract 1 from both sides. Divide by 3 on both sides. And x could equal negative 1/3. (3D). This is not set up for me to be able to start factoring or solving because it's not set equal to 0. So I need to add 72 to both sides before I get started. Then I can start down my factoring way. Can I take something out of each piece? I can take a 2. Leaves me with x squared minus 12x plus 36. So the inside of those parentheses is what I'm going to use for my box method. A times c is 36. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The sign of my last number is positive, so I can have 2 positives or 2 negatives. The sign of my middle number is negative, so I want 2 negatives. The pair that adds to be negative 12 would be negative 6 and negative 6. So I have x squared in the first box, then 36, negative 6x, and negative 6x. Out of the first row, I can take an x out. The last row, I can take a negative 6 out. The left side, I can take an x out. The right side, I can take negative 6 out. So my factored solution, the 2 from what I took out in the beginning, then x minus 6, x minus 6. You could write that as x minus 6 squared. That's okay. The directions didn't say to solve, or they didn't say to factor, so we're going to solve it. It means we're going to set each piece equal to 0. The 2 doesn't have an x, so it doesn't need to be set equal to 0. But x minus 6 does, and x minus 6. So we're going to add 6 to both sides. And we get that x could equal 6. You don't have to list it twice.